So I will talk about post-seismic reconstruction techniques for masonry buildings, as we know that masonry buildings are most of the buildings which was built in past times in our country, in Croatia, and in all of Mediterranean area. So we have stone masonry buildings, or we have brick masonry buildings. So in Mediterranean, in coast cities in Croatia, we have more stone masonry. And as Tomislav said before, in Zagreb we had more brick masonry. So one of the work packages of this project was seismic strengthening methods. And as we all know, some research were made about techniques which used in strengthening of our structures. So here we will talk about masonry structures, and reinforced concrete structures was inside, but as I said before, the reinforced concrete structures are not so vulnerable in earthquakes as the masonry structure is. So they are, but our experience from Zagreb and from Petrinja was like that when we came to assess a building, we just asked users, is there any reinforced concrete element? And they said, oh, we don't know, maybe here. And then we take a hammer and just take a probe if it is concrete or it isn't. And when we felt that is a concrete part or some stiffening element, we were sure that the building is much safer than it is if it was all about just masonry. So as Tomislav said, in Zagreb we had a lot of unreinforced masonry, brick masonry. We had a lot of wooden floor structures, wooden beams with layers of timber and isolating materials. And a lot of our buildings were not like we wanted to be like a box. He said it before. So the main problem is in renovation and strengthening of our structures. First, to connect all of the walls together, to stiff the floor structure, to make some box effect with our house. And then after that, we can go to some stiffening methods, to strengthening methods. Because if you are familiar with the softwares for calculating the strengthening methods, they all presume that we have box effect. Nobody talks about this kind of solution. Everybody, when we use the softwares of producers of some FRPs or FRCMs or something like this, of strengthening systems, they all talk about, okay, we presume that you have stiff floor structure that houses like a box, and then you can strengthen your wall with our products. So that's it. This is, I think, important to know. Okay, this is something from a presentation I have here before. So we all know that you are here from all of parts from countries which participate in these projects. So you are familiar with problems in your country and with the methods which we will use. But I think that we all have the same problems and we will use the same methods because, for instance, in Croatia, when we are talking about strengthening with some composite materials, we are always rely on Italian experience, Italian codes and prescriptions, let's say, how to do that. So I said that most important is that we have box effect. So here are the three pictures which presents first picture, A picture. This is a structure without rigid diaphragm and without good connection between walls. So when earthquake appears, the walls can collapse out of plane. So this is not good. First of all, we have to connect the walls together. So we have few methods to do this. After that, if we had connected walls, the situation is a little bit better. But also, when we have connected walls, this is the middle picture. You can have out-of-plane deformations on the wall. You can see that on front wall because you don't have rigid diaphragm. You don't have rigid concrete. Not concrete. You don't have a rigid floor. And third picture shows the, let's say, good building which have rigid floor structure and good connection with walls. So our first task is that we should do that. After that, we can calculate capacity of walls, and then we can strengthen the walls. Why rigid diaphragm important? Because if you have flexible diaphragm, the forces are divided differently than when you have rigid floor structure. When you have rigid floor structure, the forces are divided on the walls by their stiffness, and when you have flexible, by their area, and the forces are not so evenly distributed, so you can have these out-of-plane effects and a lot of problems. So how can we do that? So these are some older pictures, and I have on the presentation some older drawings and some new ones. So first of all, if you have, for instance, stone buildings, you can connect the walls, the angle of walls with some new stone elements to connect these walls together. Or you can, for instance, stiff the walls with pre-stressed cables or some systems. You can pre-stress the walls so you can attach them that they can work together in the earthquake. So this is some cross-section of wall of angle of two walls, cables, and some anchoring systems. This is Masonry. So you can do that. On that slide, you can do this. You can see the anchors practice. So as I know, the old city of Dubrovnik has not a problem. They do a renovation of old city a long time. They started to do a long time ago, and then each year they renovate some or strengthen some part of the old city, some block. I don't know the exact amount, but I know that they do that. We were talking with them with some office of cultural protection of city of Dubrovnik a few years ago. And they said that they use this pre-stressing of wall and injecting the mortar into the wall between two walls, because sometimes they have two-leaf stone wall, outside leaf and inside leaf, and inside of the wall it's some kind of debris of stones and everything, some material, and they injecting the mortar inside, and they have problems with that. They want to do something else, but there is a problem because this is all city is under cultural protection. Everything is visible. You don't have a facade. You can hide anything. So the only method they can use is this kind of pre-stressing. I know that 20 years ago I heard that there isn't possible to, for instance, to do reinforced concrete floors. It would be good that inside of the building you can do some reinforced concrete floors, some stiffening elements horizontal along the perimeter of the building. Inside of the building, nobody could see it. On the ceiling, you could have wood. On the floor, you could have the old floor with planks, with everything. You could have also wooden beams. Floor would be inside and hidden, but they don't allow civil engineers to do that. So that's the problem. The only way of strengthening is this. And with this injecting of mortar is problem that sometimes they have voids inside of the walls about they don't know that they are inside, and this mortar can appear in the sewer system or in the everywhere, so, or start to pouring out from the walls somewhere. So the other thing about strengthening and stiffening the floors is that in Zagreb, for instance, where also we have a lot of wooden floors, we can use some wooden planks or wooden plates to stiffen the wall for shear in its area. Or the important part is that connection between floor beams and the masonry is not good. So these sketches are from our some kind of manual about which we published on our faculty after the earthquake about strengthening of concrete of masonry structures, and it shows how you can, one example, how you can connect the wooden floor beam to existing masonry. So when we finish this stiffening of floor structures and connecting the walls together, we can do some repairing and strengthening of walls. So this is example from one building in Zagreb where they injecting the mortar in cracks to repair the cracks of the masonry. Also, you can use some strengthening of or repairing of masonry walls with dowels, with reinforced concrete dowels. For instance, this is the crack which came from the shear collapse of the wall, and inside and outside of the wall you can have some holes and inside, and they will increase, they will repair, not repair the crack, they will increase the capacity of the wall, and the crack, after that you can repair the crack. Also, when we are talking about I'm going back to the floor systems. When we are talking about stone masonry, this is one example of double leaf stone masonry. So this front of the wall, this is the side of the wall, and this is some kind of material inside of the wall. So you can put protection mortar here, and if you can make reinforced concrete deck and finding elements, can connect these two elements and hide it from the front, and that will be okay. So another thing for connecting walls together can be connecting walls with some kind of steel elements which you can put in the joint between the bricks or stones, or to stiff the angle with some kind of steel bars or something inside of the holes which you can bore, which you can drill in the wall. As I said, the important role in which we see in Zagreb was when the structure had the confining elements. The behavior of the structure was much better. So, if you want to strengthen the unreinforced masonry building, the one way is to have confining elements. So they can be vertical in the angles of building, or at the sides of bigger openings, windows and doors. And you have horizontal confining elements which would be along the floor structure, and that will be okay. So that kind of strengthening will be much better. So after that, and this is, as I know for now, most common method in renovation. So you have to know that in Zagreb, engineers from practice like to use much common methods than I will say something about FRPs or FRCMs or something like that. they use it, but the most allowable method is to shotcrete the wall, or even to put the new reinforced concrete wall inside of the building, if this is allowable. So the problem is with cultural heritage. You couldn't damage the building, left the front facade, and build inside reinforced concrete box. This would be most allowable way for every of other our engineers, because they know how to calculate new buildings. We were all in the same problem 2 years ago. How to calculate old building. I'm teaching students about reinforced and concrete structures and masonry structures. My professor, my mentor, my PhD was 5 years ago published a book about masonry structures. This was only one book in Croatia on Croatian language about masonry structures, about according to Eurocode 6. And nobody asked about that book, just students. When earthquake appears, everybody called me, oh, where can I buy this book? I need this book. And everybody started to be a very big experts in masonry structures. And before that, nobody cares about masonry structure. Nobody calculated the masonry structure. I'm sure that nobody knows how to calculate new masonry structure. But now they are all very big experts. And when we are talking about strengthening, nobody deals a lot about strengthening and calculating these shotcrete walls, walls reinforced with FRCM or FRP with bars or with strips or with any sheets. They just like to calculate. They like to have a building in which they could put new reinforced concrete floor, reinforced concrete walls, and calculate the building as it is new. I don't like this. It would be much. Somebody, maybe you asked why it would be much easier to demolish the building and to build another one. Okay, we are not in the United States. They have everything in concrete or in the wood, and they put a facade and they make a building which can look that is 500 years old, because their history started 200 years ago. We have a lot of buildings which were very much, we appreciate them and they are important, and we couldn't do that. So in Zagreb, it's problem that every building is under some kind of protection, and here it will be maybe much bigger problem. Even in Dubrovnik, I couldn't say. So there are some details about shotcrete walls, about connecting the shotcrete with the wall. This is so important. I already said a lot about it. This is a shotcrete wall around the stone masonry wall. So that's good way when you don't care about the wall, when you just have to stiff it, not to preserve the original look. And now we came to finally to little bit modern techniques, which is some fiber reinforced cementitious matrix system, which now it's more and more used in Croatia. These are pictures from some after earthquake renovation in Zagreb. But also there is a problem that people use this without any design. Just they put it on the wall. There's not much, and there is not high level of knowledge about how to calculate this thing. And there, we are here to do that. I'm and Mislav, we are trying to teach students how to do that. We are trying to give some diploma thesis to students to do something with that we can have calculations, and that we can show this to engineers in practice. So there are some details, and I think that I said all. Mislav said a lot of before me, and in some kind of